Okay, so a little help with the tsunami lab. So certainly you should look over this lab tutorial video. That's why I made it, so you could have some help with that. But if that's not enough, no worries. What I'd like you to do in the first couple questions here is you need to plot the locations of each of these points here. So there are 24 points. They each have a different longitude and latitude. Because your mission here is, once you plot them in Google Earth, is to figure out which one was the closest, which one was the farthest. And so the idea is that when a tsunami wave hits the coast, for some reason, water travels very far in some areas, and it doesn't in others. We want to first identify those and then figure out why. And so this is an elevation here. That's the height of the water at that location. We want to know how far it went in. It's inundation. So how far did it run in? And so how you can do that is you just need to highlight the longitude, latitude, copy that, go to your Google Earth, paste it up here, and hit the search bar. And don't do anything. Let the program locate that point. And then once it stops moving, you'll come up here to this plus place mark, add a place mark. You click it, it'll bring up this pop-up window. Now, when I first did it, it kind of went behind my Google Earth, so I had to close the window to find it and pull it in here. So, but you can't find it, it's probably behind one of your windows or tabs. And so you can call it whatever you want, but they are numbered 1 to 24, and that's the answer that I want you to put in there. Like, which one was the farthest? Oh, it was number 22. Which one was the closest? It was number 1. So this is location 1, so I'm just going to type in location 1 and then hit OK. And now I have location 1. So yes, you're going to have to go back to here and then do another one. So we'll do location 2. So you highlight that, you right click, copy, come to here. We're going to paste a new one, and we're going to say, please find that one. And so you have to wait, let it settle, or it'll mark it in the wrong place. So once it stops moving, we're going to add a second one. We're going to call this one location 2. And the idea is you'll have to go through them all, and then once you've plotted them, you can kind of zoom out. And because there's 24, you don't have to measure all 24. They're kind of all in this area. You should be able to visually see which ones are the farthest, which ones are the closest. So there might be 3 that are candidates for the closest. What you'll do is you find those 3, you come up to the ruler tool here. You want to make sure it's aligned. It doesn't matter the units you use as long as you're using the same so you can compare. But I would just, first I'm going to zoom out a little bit so I can see the coast here. And I'm going to click here and then draw a line the shortest distance to the coast and say, okay, that one's 3.06. I would probably write that down for that location. And then I want to do another one. So what's this one? I click this one. Oops. So I click it. I got carried away there. Click once. Come to here. Click that one. So that's 3.40. So location 2 is closer than location 1. And so in the lab, it's asking you to tell me, let's see, which one went the farthest from the coast. So like I said, after you plot all 4 of them, or sorry, all 24 of them, you'll look at your map, get a general idea of which ones are closer and farther so you don't have to measure them all, and find out, if there's one way back here, another one over here, another one here, maybe those are the 3 farthest that you can visually see. You just measure those 3 and you pick the one that's the farthest. Then it also asks you for the closest. Same thing, find the couple that are the closest, zoom in or out, so you can get an idea, oh, it's this one and this one. Measure using the ruler tool, the closest one, that's the answer. Okay, so that's what it's asking you to do in this first part here. So when it's asking for what's the maximum miles, right? So, okay, so I lied. I guess miles is what you want to measure and not kilometers. So give me the 2-digit location, or in some cases it's a 1-digit. Is it number 5, number 17, number 22? So that's what I want for question 1. And then how far was it, roughly? So 4.2 miles. Okay, great. That's the answer for that. And then the closest. So you do need to plot all 24. Find the ones that are farthest. Measure the couple that are the competitors for the farthest. write down the number that's the farthest and how far it is, and then do that for the closest. So that's this first part here. The other part that seems to give people some grief is doing the math for sure. So once you plot all 4 of these, you will need the earthquake epicenter also plotted for a question here. So while we're there, you'll want to highlight this, copy that, jump over to our lovely Google Earth. We're going to paste that in there. Let me get rid of this because I'm done with it, and search that. And so the earthquake happened off the coast where the 2 plates meet. I'm going to wait until it stops moving. I'm going to add a place mark, and I'm going to call this epicenter because I'll need that for later. So now I have that on my map. So I can zoom back out, and there's my epicenter. There's a bunch of locations there. So as you move through the lab, it asks you a few questions about why you might have things go farther or closer. But then you get into, let's see, so some of the issues were with the speed here. And so when you're given this, it's basically just showing you how you can calculate how fast a tsunami wave is moving. And it's really based on the depth of the water. In general, the deeper the water, the faster it moves. Now, it's telling you this formula will give you the answer in meters per second. That's the speed units, the velocity units it's using. What you need to do to calculate that is use 9.8 for the gravity constant. And whatever depth you're given, you need to multiply those 2 together. Take the square root of that. So look, on your phone, at least on my iPhone, if I have it held in normal mode, portrait mode, and I can do some basic calculations, if I rotate it, it'll give me more options like a scientific calculator. And there should be a square root button there, so you can just hit square root, and it'll give you the square root of that value. So that's what this is asking you to do here. It's the same number that's above, but it's asking you to calculate how fast the wave was moving in the 2011 event. This is how deep it was where it was first initiated at the epicenter. And so we want to use this formula. So, all right, I'm going to attempt to do this for you. Let's see. So I'm going to jump over here, and then we are going to try to do this. I'm going to drag you over to here. So here is a little PowerPoint that I made. And so what you see here is, let's see if I can get this to work for me. All right, we're going to make some adjustments. I apologize for that. But all right, so here's the formula, the speed of the tsunami. And so what we need to do for this is we need to take the 9.8, okay, and we're going to multiply that by the depth, which is the d, and that's going to give me this number, 41,650. Now the units are actually meters squared per second squared, because meters times meters is meter squared, and the second squared is carried over to here. But this isn't the answer. Remember, it's under a square root sign. So we need to take the square root of that. You're just going to plug that in your calculator, and hopefully you'll get 204 meters per second. And you're usually like, yay, that's awesome, but it's not, because we want it in, my apologies, in miles per hour. And so we need to do a conversion for that. So how do we do that? So what we need to do is find something that has that's equivalent, a conversion factor. And here they are to the right. These are some basic conversion factors that we use in this class. We do have the metric system that we work with. So meters to kilometers, there's 1,000 meters in every 1 kilometer. There's, I made a mistake here, you'll have to bear with me, 1.61 kilometers in every 1 mile. And there's 3,600 seconds in every hour. So we're going to go step by step, so it's going to take a few steps here. You could do this if you understand conversions in a one big step. But basically I have meters and seconds. I have to change both of these. Meters has to go all the way to miles, and seconds has to go all the way to hours. So I'm going to change meters to kilometers first, and then I can change it to miles. And so I'm going to use this conversion factor. This distance is the same as this distance. And I can multiply it by this because this is essentially 1. It doesn't affect the numeric value of this, right? So this is how we do conversions. What this does for me is it allows me to cancel the meters. So this meter unit and this meter unit go away. And now I just multiply across, and what I get is I get 204 times 1, but the meters are gone, so I'm left with just kilometers. And 1 times 1,000, which is 1,000, but the meters are gone, so I get seconds. So I get 204 kilometers for every 1,000 seconds. If I do the division here, I end up with 0.24 kilometers for every second. That's a speed. It travels 0.24 kilometers every second. But we need to change that, of course, because we want to end up in miles per hour. So here is, we can write this 0.24 kilometers per second like this. It's really a 1 second. We just don't write the 1 because it's redundant. But we start out like this. Now I want to get rid of some stuff. Let's get rid of kilometers and change it to miles. I need this conversion factor. It's given to you in the lab. It is that 1.61 kilometers is exactly the same as 1 mile. So because I put my units that I want to get rid of opposite each other, one in the numerator, one in the denominator, I can get rid of kilometers. Now I'm left with miles per second. Now I multiply the top and the bottom across, and of course I just have 1 times 0.24, so I get 0.24. Kilometers are gone, I'm in miles. 1 times 1.61 is just 1.61. Kilometers are gone, I'm in seconds. And then if I do this division on my calculator, I get 0.15 miles for every second. Once again, that's a speed, it's a velocity. I have to do one more conversion. I need to change my seconds to hours. So I rewrite this so that 0.15 miles is on top, 1 second is on bottom. I want to multiply by a conversion factor, where the top and bottom are the same amount. They're just in different units. Here's my conversion factor. I put my seconds opposite each other. As long as they're one's on the bottom, one's on the top, they will cancel. My seconds are going to go away. I multiply across. When I take 0.15 times 3,600, I get 540. Seconds are gone, so I'm left with miles. 1 times 1 is 1. Seconds are gone, I'm left with hour. Holy crap, 540. And we can write it like this, miles per hour, which really means this. It's 540 miles divided by 1 hour. We don't say that, we say 540 miles per hour. So that is actually the answer to one of the questions in, let's see, question 13. So question 12 wants it in meters per second, and then question 13 wants you to do the conversion. So I know that probably made your head spin, but you should be able to do these conversions. They look messy, but you just take your time. As long as you know the conversion factors, you can do that. All the rest are just asking you to tell me what the time was. And remember, there's a time factor conversion here. So I'm going to bring you back over here. Whoa, hopefully not make you dizzy. And here it says time equals distance divided by rate. So we have the rate. That's what you went and calculated up here. 540 miles per hour. So I have the rate. I just need a distance, and I will get time. My rate, remember, is in miles per hour. And so this distance needs to be in miles. Okay, and how do we do that? Well, it caused minor flooding in this location. So how far is that from the epicenter? Well, I know where the epicenter is. Now I need to find where this place is. And so I can certainly do a search. Paste. Search, please. And so this far away, holy cow. So what I want to do is, I have to zoom out so I can see both locations. My epicenter, holy love of God. Okay, here we go. Here's my epicenter. So how far is that? I have to measure that, right? And remember, it's got to be in miles. So I want to start here, and I want to go, I'm going to zoom out. Let's scroll. Oh golly, that didn't work very well. Let's scroll. I'm clicking and move and dragging, clicking and dragging, clicking and dragging. Zooming in a little. There it is. Clicking and dragging, zooming in a little. So when I click, I can drag and drag without stopping the line, right? So I can zoom in, zoom in. Here's the island. I'm going to click right there on top of it, and it's going to stop. So it's 2,786 miles. That's how far it is away from the epicenter. And so what do I need to do? I need to plug that in here. Okay? And so distance, I plug that value for the distance, I divide it by the rate. So remember, miles divided by miles per hour, I'm going to get rid of the miles. I'm going to end up with a time in hours. So how long did it take to reach that in hours? Boom. You just do the division and put the number there. And so same thing, Hawaii. What is the distance from the epicenter to Oahu? So you got to go find Oahu. Draw the line all the way to there. Just click and drag, click and drag. It's going to take a little while to get there. Once you get there, tell me how far that was. Do the division. And then finally, you have this one here. It's the same thing. So you're just going to do, let's see, what does this say? What is the distance? Tell me what it is. And then tell me how far it was, or how long it took to get there in hours. All right, so hopefully all the craziness tonight, there's some mistakes for sure as I was doing this video, so I hope it didn't confuse you. But remember, first part, you're copying and pasting the longitude, latitudes in the search bar, hit search, let it go there all by itself. When it's done, click the add place mark icon up there. You get a pop-up window and call it number 1, number 2, number 3, all 24. Then put in your epicenter. For the first 4, you need to tell me which is the closest to the coast, which is the farthest. So once again, like I said, you don't have to measure them all. Just eyeball which ones are the farthest. And if there's a few candidates, measure just those 3 or 4. Tell me which one's the farthest. Tell me how long, how far it is. Shortest, do the same thing. Then when you come down to this speed of the wave thing, right, follow along with the math. Do the conversions. But look, really I'm giving you the answer to that, which I'm okay with for here, for 13. But then you need to be able to use that answer here. So measure the distance, put in that number. Just the number, right? Don't put miles, just put the number. And then you're taking that distance you just measured and you're dividing it by that 540 we came up with in question 13. And that should give you a time in hours. And then measure again, do it again. Measure again, do it again. And so that's kind of how the lab's going to work. I'm hoping that I didn't overwhelm you with the conversion stuff, but it is something. We're going to do a few more conversions in the groundwater and things like that. So maybe it's useful for you to kind of see that. All right, so hopefully that's helpful. If you have any more questions, please don't hesitate to reach out to me.